Such an impact might have seeded our moon. When Earth was just 50 million years old, it was probably struck by a body the size of Mars. But there's a twist to this intriguing theory. The collision was a glancing blow. 2 days later, the impactor returned. This double whammy, a bad weekend on Earth, could well have blasted enough material into orbit to form the Moon. Most likely, our planet had received the luckiest one too. Quickly, in no more than a year or two, a molten moon was orbiting a molten Earth. And at 20 times closer than today, the moon loomed huge in earthly skies. The gravitational pull between the two was immense, but most importantly, the moon's rotation became captured. In one orbit of Earth, the moon turns once on its axis. In other words, the moon always presents the same face to Earth. And here is that face. From Earth, we never see the far side of our partner in space, albeit a junior partner. For the diameter of the moon, at 3,500 kilometers, is 1/4 that of Earth. At a distance of some 384,000 kilometers, the moon takes 27 1/3 days to orbit Earth. As it does so, the moon appears to change shape, what we call lunar phases. To understand them, we must view Earth and Moon from space. With the sun shining from the right, exactly half the moon is always lit. It's reflected sunlight, because the moon has no light of its own. But from Earth, as the moon swings round its orbit, we see varying amounts of that half-lit surface. When we see only the dark side, it's new moon. When we see all the lit side, it's full moon. Remember, the shadow is cast by the moon, not by the Earth. To many, the moon is both familiar and strange. What, for instance, are the dark patches, those so-called seas? This one is Mare Humorum, the Sea of Humours. And this, a great bay opening into the Sea of Showers, Mare Imbrium. Here, the northern rim of Mare Imbrium, with, above, the dark crater Plato, and to its right, Alpine Valley. Mare Imbrium is the dark terrain on the right. Contrasting with the brighter uplands, it's 1,300 kilometers wide. But mare aren't oceans, they're basins gouged by impacts. Here comes the big one that formed Mare Orientale. Post-impact, lava welled from beneath and cooled into a sea of dark rock, a mare. Such major impacts suddenly stopped 3.9 billion years ago. Nearly a billion years later, volcanic activity also ceased, as the moon's interior cooled. But smaller impacts continued to pockmark the lunar surface. Craters proliferated. The Copernicus crater. A quartet of craters. Clavius, with younger craters inside. This moonscape records impact after impact. No water or wind erodes them. No atmosphere lessened their force. All that erodes old craters are new craters. The youngest craters are surrounded by splashes of bright ejecta, such as this. Like pebbles hitting mud, ray craters are the brightest features on the moon. Around the rims of big impact basins, mountains are thrown up. These are the Apennines. The moon has clefts and rifts and winding rills like this, channels where lava once flowed. With 81 times more mass, our planet is very much the senior partner in the Earth-Moon system. Lunar gravity is 1/6 that of Earth. Witness the antics of the 12 Apollo astronauts who landed there over 30 years ago. And with no air resistance, they showed how a hammer and feather fell at the same speed. In this magnificent desolation, as one astronaut put it, temperatures can reach 120 degrees Celsius by day and minus 160 at night. Astronauts became geologists during the landings. 6 Apollo missions collected rock and soil samples totaling 380 kilos. To speed the process and extend sample range, moon buggies were used during the last 3 landings. It wasn't all flags and footprints. The last samples were carried home in 1972. Analysis revealed they were very dry and either volcanic or the product of impacts. They were like rocks in Earth's upper mantle. At the end of each mission, landers were crashed back into the lunar surface. The moon rang like a bell. It indicated pulverized rock, reverberating just beneath the surface. The moon's interior is probably solid, its core metallic. But that core is much smaller than expected, 1/5 of the lunar diameter. By comparison, Earth's core is more than half the width of our planet, a disparity that suggests different origins, which backs the notion that the moon was born of an impact with Earth. When it formed, the moon was 22,500 kilometers from Earth. Today, it's nearly 20 times as far, and getting farther. We know through lunar laser ranging. Apollo astronauts left reflectors on the moon. From this instrument in Texas, scientists with pinpoint accuracy measure the transit time of laser pulses bounced from the reflectors. This reveals the distance of the moon to within a centimeter. Currently, it's some 384,000 kilometers away, and it's receding at 3 centimeters a year. The cause is tidal drag, the gravitational pull exerted by the moon on our oceans. Although the sun has a little influence, the moon, shown symbolically here, causes a tide to rise in just over 6 hours and to fall again in the same time. Twice a day, around the globe, tides rise and fall as the moon tugs on the oceans. They bulge at either side of Earth and are pulled ahead of the moon because of the faster spin of our planet. But tidal drag is slowing that spin, and our day is getting longer as moon and Earth pull farther and farther apart. The moon has another effect. It keeps Earth on an even keel. But suppose we lost the moon. We'd be all over the place. With the moon no longer pulling on the bulge at Earth's equator, axial stability would be gone. Over millions of years, we'd wobble chaotically, tilting from 0 to 85 degrees, and our climate would be shot. Imagine the nightmare as we keeled over. Ice would girdle the equator. For the first half of the year, ice would spread far into the southern hemisphere. 6 months later, the northern hemisphere would be enveloped, as ceaseless sunlight bathed the south. This could be Egypt. The Sahara, a howling waste of icy blizzards. Antarctica, a blazing desert. It may sound science fiction, but it's not. For in a billion years' time, when the moon is far gone, Earth will wobble.